Dear students, this video is the continuation of the previous video. Now we'll see here the adjacency matrix for the weighted graph. Now this is the given graph. Okay, how many vertices? 1, 2, 3, 4, 5. Here why they given the numbers? Suppose you take this one is Sohar, this number 2 is Muscat. Just for example, I'm telling. Then how much distance between these two vertices? That is 500 kilometer. Simply maybe they give 5. Just I'm telling. For example, this is 5. Y is given. This is called weighted edge. This is called the weighted edge. This is the edge, the line between two vertices. Why we say 5? Because of the weight. You can say this is 500 kilometer or 5 kilogram or something. Now you write all these 5 vertices in row as well as in column. Why? Because we are going to write the adjacency matrix for the vertices. Okay. Now, as we have seen in the previous video, you see this vertex is adjacent with how many vertices? 1, 2. Vertex 1 is adjacent with vertex 2 and vertex 5. Now you see vertex 1 is adjacent with vertex 2 and vertex 5. That's why I put 5 and 1, because this is 5, 1 2 is 5, 1 5 is 1. Okay, if you write this vertex 1 and this vertex 2 is here 5, then you would write 2 1 also 5, because this is a symmetric matrix. Similarly, you can write here, see, 1 5 you wrote 1, so that you write 5 1 is also 1. Simply I can say, if you write this row, you would write this column from this one. So except 0, just you copy all this here. Similarly, for 3, see 2 and 4 adjacent. I'm telling what is this, 2 and 4 adjacent with 4 weight and 2 weight respectively. So now for 3, you can write here 4 weight and 2. Okay, if you write, see, if you write this value, then down to this 4, sorry, down to this 0, you have to write these two values here, because this is a symmetric matrix. Adjacency matrix is symmetric. Okay, now we'll see the adjacency matrix for this pseudograph. Okay, now how many vertices? A, B, C, D. You write here A, B, C, D. Now A, B, C, D. Now we are going to write adjacency matrix for the vertices. Okay, now you see here, this vertex is having 3 edges with this vertex B. So A and B having 3 edges. So write 3 between this. Now A and D having 2 edges. So now A and D 2. So if you write, see in the first row, if you write 0 3 0 2, then after this 0 you write all these 3 values down also, because this is symmetric matrix I am telling. So 3 0 2, write 3 0 2 here also. Similarly, you can write you can complete the adjacency matrix for the vertices B, C, D. You completed this. So similarly, you write B, C, D. This is the adjacency matrix of this pseudograph. Here we are going to see the adjacency matrix of the directed pseudograph. Now you see here, this is the directed pseudograph, but this graph is disconnected, because see here, this part is not connected with this part by any edge. It's okay, but anyhow, this is the graph. Okay, now you see here, you take the first vertex 1 and 2. Listen here carefully. Now you write first all the vertices 1 to 6, 1 to 6. That is simple. Next you take 1. This vertex is connected with 2 vertex. You must see the arrow now. See here, this from this vertex 1 one edge is going. So this is the initial vertex. So this is the terminal vertex, initial and terminal, because this is the starting point of this. I am telling about this edge. Okay. So now 1 is adjacent to 2 by this arrow, so that I write 1, 2 is 1. This is not the symmetric matrix in the directed. You cannot write directly 2, 1 is 1 unless otherwise this is given. Now you see this very carefully. See, vertex 2 is adjacent with vertex 1 by this arrow, by this edge. This is the direction. So this is the initial vertex, this is the end vertex. That's why I write 2, vertex 2 is adjacent with vertex 1. That's why I write 1 here, because of these two vertices. Suppose only this is given, you have to write only this 1, 2, 1. Cannot write this. Now this arrow is given, this edge is given with this arrow. That's why I am writing here 1. That's very important. Okay. Now you see here. Now you can understand the difference by seeing 1 and 4. You see here 1 and 4. You see 1 and 4 here. You see 1 and 4. From 1 you don't have any arrow. See, you see here 4. From 4 you have 1, because this is the initial, this is the terminal for this edge. So that I am telling from 1 no, nothing is going to 4, but from 4 is going. That's why from 1 to 4, you see, from 1 to 4 I am writing 0, because here 1 to 4 no edge with arrow as initial point this, terminal point this, no. But you see 4, 1. Now you see 4, 1. This is very important. This is very important. Marking 1, 4, nothing. 1, 4, 0. But 4, 1, yes, it's going 1 gauge this direction. Initial point, end point. So that I can write 1. So similarly, you have to fill this matrix for all the what is that? Now you see this is very interesting. Vertex 3. For example, you see 3. You see 3. You see here from 3 here, no, it's not going, it's coming, not going. So here 3 to 0. You see here 3 to 0. 3, 4, yes, 0. Because 3 to 4, no edge. 4 to 3 is coming, but not like this. Not like this. No. 3 to 4, not like this. Therefore, 3, 4 is 0. Now, but 3 has one loop, which means starting and ending. Now that's why I write 3, 3, because it's starting and ending in the same place, loop. So I put 1 here. I hope you understand now how to make the adjacency matrix for the directed pseudograph. Now, incidence matrices. See, we have seen 4-5 questions how to make the adjacency matrix for the given graph, simple graph, directed graph, and pseudograph. Okay. Now we are going to see incidence matrices for the simple graph. Now you see here 1, 2, 3, 4. We have 4 vertices. Now you see incidence matrix means what? Here you write only vertex. For each row you give the vertex V1, V2, V3, V4. Now for each column you write the edge. How many edges you have? How many edges you have? No issues. You list everything. Now E1, E2, E3, E4, E5. You have 5 edges. So now write here edges. That is the only one difference between adjacency matrix and incidence matrix. In adjacency matrix, you write here vertex, here also vertex. In incidence matrix, in row you write vertex, in column you write edges. Okay, that is the main difference. Now you see what is this matrix where Mij is 1 when edge is incident with Vi, otherwise 0. Okay, now you see this vertex V1 and edge G1 is Incident means it's touching. Now you see this is vertex v1. e1 is touching, yes, is having contact with v1, yes, that's why I can write 1. Now you see e2 is contact with v1, yes. Now for example you can say like degree. Now you see this v1 is having incident with edge e3, that's why here for v1 1 2 3 edges incidence. So now I can say 1 1 1 for e1 e2 e3. Now see here this edge e4 is incident with v1, no, so that here 0. For e5, no, 0. Similarly you can write you can complete the cells for v2 v3 v4. Now you go for v2, you will see for v2, you see v2 1 2 means 2 edges having incidence with v2, that's why you see what are the edges e3 and e4. Now you see for e3 and e4 you write 1 1 for this vertex v2, for v2 e3 and e4 write 1 1, other values are 0. Similarly you see for v4 1 2 3 edges e2 e3 e4. So now e2 e3 for v4 e2 this is e2, this is e5, this is e4. Okay, so e2 e4 e5, right? 1 1 1 for v4. Similarly you can complete the incidence matrix for the given graph. Thank you.